Good day to you, madam. My name is Jemima Kayivili and my group mate name is Radhimala Chelvi. Today we will present on the assignment. So for the assignment, we choose question number 1. And then this is the transfer function for the question 1, which is 200 j omega over j omega plus 2 j omega plus 10. And then this is the board plot. Okay, now I will give a small brief on the introduction of the transfer function. The transfer function, which is h omega of a circuit, is the frequency-dependent ratio of a phasor output, which is y omega, can element voltage or current to a phasor input, which is x omega, source voltage of or current. And then, as you can see here, this is the input, which is x omega, and then this is the linear network, which is h omega, and then this is the output, which is y omega. So for the transfer function equals to output over input. And then there are 4 kinds of possible transfer function, which are voltage gain, current gain, transfer impedance, transfer admittance. Okay, now we will obtain the general state of equation to get the board plot. So this is the transfer function, which is 200 j omega over j omega plus 2 j omega plus 10. Firstly, we will factorize the 2 over here, and then we will factorize the 10 over here, so that we will get 200 j omega over 2 times 10, j omega over 2 plus 1, j omega over 10 plus 1. So when we multiply the 2 and the 10, we'll get 20. So it will be 200 j omega over 20 j omega over 2 plus 1, j omega over 10 plus 1. And then we should simplify the 200 over 20 so that we will get 10. So it will be 10 j omega over 2 plus 1, j omega over 10 plus 1. So this is the final answer. So there are 2 poles, which are 2 and 10.
Hi, good day. I'm Radhimala Chelvi Saravanan, and my matrix card number is B082210149. And in the assignment of advanced electrical circuit, I'm going to explain the magnitude of a Bott plot, and we used this table to plot the magnitude of a Bott plot. So this is the simplified transfer function that given in the question 1. And finally, we got 10 j omega over 10 j omega over 2 plus 1 multiply with j omega over 10 plus 1. And from this equation, we can see there is a 4 thing. 10 is the factor of k. J omega is a factor of factor, and this one is a pole. In this function we have 2 poles, 2 and 10, and there is no 0. Okay, using this table, there is a factor k, which is 10. So we use the gain part to construct the Bott plot. For k, the line is in straight line, and the formula is 20 log k. The k value that we got in transfer function is 10. So when substitute the k with 10, we got 20. So plot a straight line with the dotted lines. And then the second thing is j omega. J omega is the line was going upward from the x-axis. So for one value, there is a per decade. So for j omega, we plot from negative 20 and going upwards dotted line. And then we have 2 poles, which is 2 and 10. Okay. For poles, the line was going downwards from the x-axis. The pole value, okay, according to the transfer function, here is the value of 2. So from value 2, we draw a downward dotted line for 2 decade. Because of 20n, we draw for 2 decade, and then for pole 10, we also draw a downward dotted line until 1k, which is 2 decade, 10 to 100, 1 decade, 100 to 1k is another 1 decade. So for the combination of these 4 lines are from negative 20 to 2 was the line that going upward, and from the pole number value 2 to 10, the line was straight because uh, the line between the straight line and then the slanting the upward line and downward line was deducted when 20 plus negative 20 is equals to 0. So the line was straight, and then after the pole 10, the line was there is between the 10 to 1k 2 decade was upward line and downward line. So when upward and downward was deducted is 0, and also have another downward line which is 10. So we just follow the line downward. So the combination is negative 20 to 2, 2 to 10, 10 to 1k. So this is the combination of the graph, which is for magnitude of dot plot. So as the next part,
Now I will explain about the phase mode plot. So this is the phase mode plot. And then the axis x is the omega, and then the axis y is the phase. So there is two pole, which is 2 and 10. And this is the equation for the first pole, which is 2, which is 1 over j omega over 2 plus 1. And then another one is 1 over j omega over 10 plus 1. So as we can see here, I will explain this part first. So as we can see here, the line is going down and becoming straight, and then the same goes to this line also. It's going down and becoming straight. It is due to we should look at this here, and then we should look at the p over 10 and then the 10p. So for the first pole, which is 2, the first pole line will start from 0.2 and then it will end at 20. It is because if we 2 over 10 will get 0.2, so that's why it will start from here and then it will end at 20. It is due to we times the pole with 10, so we'll get 20. And then for the second pole, which is 10, it will start from 1 and then it will end up at 100 and then it will become the straight line. It will start from 1. It is due to the over here, which is pole over 10, which is 10 over 10 will get 1, and then it will end at 100. It is due to the 10 times with the pole, which is 10 times 10 will get 100. And then over here, now I will explain the part over here. So over here, the axis x will be j omega, and then the axis y will be the phase. Okay, now for this graph, we should combine all the lines so that we could get this kind of graph. So for this line, we should see at the negative 45 plus positive 90. So we'll get negative 45 plus 90 will get positive 45. So that's why it will go up. And then for this part, we should look at this from here to here. So it will be, this one is the negative 45, and then this one will be the negative 45, and then we should add with the positive 90. So it means negative 45 minus 45 plus 90 will get 0. So that's why we get the straight line of constant over here due to the 0. And then the line over here is going down. This is due to the negative 90 and then negative 45 over here and then the positive 90 over here. So negative 90 minus 45 plus 90 will get negative 45. Due to the negative 45, the line will go down. So this is how the phase word plot works.
I did the second part, which is change the bot plot from bot plot to transfer function. So this one also we use the table that I showed this one. So from this table, we can assume that when the line was going upwards, it's a 0, and when going down is pole. So 0 is 5, and 10 and 100 is poles. K is constant. Okay, this one, when going upward, there is a 20 dp per decade. But when going down, it's negative 40 dp per decade. So this one is the power of 2. So K factor constant is 1 plus j omega over z is for 0. K is constant, use 20 log K. And this one is 1 over 1 plus j omega over poles, power of n, because this one for 20n, this one only 1 decade. This one is 2 decade. Okay. This is for 0, 1 plus j omega over 5. For pole 1, 1 over 1 plus j omega over 10. For pole 2, 1 over 1 plus j omega 100. So for constant, we got 10. We use 20 log K plus log slope at first line. So slope at first line is 0. So we add 0 and then using an anti-log 1, and we got 10. So this is a transfer function of this bot plot. Normally the constant and the 0 was at numerator, at denominator was the poles. So we arrange according to what I said just now. Constant, the 0 and the denominator was filled by the poles. And here square, because we use 20n, there is a slope which is negative 40 dB. So after this, we solve this equation. First of all, I just use K, because if I use the K value, 10 first means it will be complicated to solve. So I first just fill up with the K, and then I first solve the denominator because of the square, and then there is a fraction inside the function. So I just simplify, factorize with 1 over 10 plus multiply with 10 plus j omega, because 1 over 10, when cut 1 10 we will get 1, so 1 plus j omega over 10. So this one is 1 over 100 square multiply with 100 plus j omega square. So after we multiply 1 over 10 and 1 over 100 power of 2, we will get 1000 divided by 5 and times with k, and then the fraction all will cut off ready, and then we just simplify everything, multiply, substitute the k value, and finally we got the transfer function 200,000 multiply with 5 plus j omega over 10 plus j omega multiply with 100 plus j omega square. And this is the transfer function of the bot plot that given in the question 1. In conclusion, we're able to obtain general state of the first equation to get the bot plot. Then we're able to plot magnitude plot in semi-log graph. Next, we able to plot phase plot in semi-log graph. We able to explain in detail about the graph and understand it clearly. And lastly, we understand on how to find transfer function from the dot plot. And that's all from us. Thank you.